Our next session is about Spring GraphQL, which offers an alternative to REST web APIs. If you don't know what GraphQL is, that's okay. You're in the right place. I'd like to welcome Rossen Stoyanchev and Andreas Merrick, who will help us understand what the Spring GraphQL project can offer and when to make use of it in our applications. I'll turn it over to you guys.
Hi, everybody. Welcome to our talk about Spring GraphQL. My name is Andy. I'm one of the current GraphQL Java co-maintainer, and I'm the creator of GraphQL Java. I'm a general active community member of GraphQL. I'm also one of the Spring GraphQL co-creator. I'm talking to you now from the middle of the night from Sydney, where I work currently for Atlassian. You can meet me and reach out to me on Twitter and GitHub as @AndyMurray.
And hello from me. My name is Rossen Stoyanchev. I'm a Spring Framework committer focusing on web development, Spring MVC, Webflux, web messaging. Also contributing to our sockets, and I was involved as well in the creation of Spring GraphQL along with a few other colleagues working at VMware.
Okay, so what is our agenda today? We have 3 parts. Each part will build on top of the previous one. First, I will talk about what is GraphQL, to give you a brief introduction if you never heard about it, to give you some ideas how to think about GraphQL. And then I will talk about GraphQL Java specifically. And finally, Rossen will take over and give you insights into Spring GraphQL itself. Okay. Let's start with a kind of obvious question. What is actually GraphQL? In a general sense, GraphQL is a technology for client-server data exchange. This means a client wants access to data on a server, normally across a network. Originally, it was actually developed by Facebook for their Facebook iOS app back in 2012. It got open sourced in 2015. We will talk about a little bit more later what open sourcing means actually in this context. Currently, it is governed by a non-profit foundation where a lot of well-known companies are part of, Airbnb, Atlassian, Twitter, to name a few. Generally, we have 2 pillars we want to deep dive today a little bit into. We have a statically typed API, plus we have a query language which defines how to take advantage of the statically typed API. When you're asking yourself now, if you're asking yourself now, when do you use GraphQL? Well, the general sweet spot at the moment we can see is are single page apps and native clients. And not surprisingly, as GraphQL was developed originally for the iOS app. But it's not restricted to this. I see successful applications of GraphQL as public APIs, most notably GitHub and Shopify, for example, but also service-to-service GraphQL is successfully used. But in general, the sweet spots are single-page apps and native clients. Also, to make this clear, if you start a new project today, you would not start with GraphQL and REST normally. GraphQL itself, as a general purpose technology for client-server data exchange, is an alternative to REST. So if you start a new project today, you would normally choose one or the other. Okay, so why we could talk a lot about where GraphQL is different from REST or maybe even SOAP. My personal favorite argument for GraphQL and why I think it's so successful over the last years is the overall developer experience. And in order to showcase this, I have a small demonstration for you. What you see here is a web app called GraphQL. It's a general web app which lets you explore interactively every GraphQL API. And on the left, you can see a GraphQL query. This GraphQL query runs against a demo application we built, which is listing employees of a made-up company. If I execute this query, I will get all employees of this company with every employee name plus the name of the department they work in. As you can see on the right, the JSON structure we get back matches the query we sent to the server. If I want to ask for more data, I can do this by selecting or typing more fields in a code completion sense even. So I can select now a salary, for example, for every employee. If I fire the request again, I will now see the salary. One important aspect, every field you request, you get back, and you will not get back more. That's an important aspect of GraphQL. We will come back later again. The last part I want to highlight here is on the right, what is called the Documentation Explorer. That is a general feature built into GraphQL, which lets you introspect any API and gives you meta information about the API. In this case, I can click through and see, for example, the field I have available here is all employees, which gives me all employees of the company. Each employee has 4 properties, 4 fields, ID, name, salary, and department. I can click into the department and see the specific fields. I want to highlight here and stress here that this web application we didn't build at all. You can run this web application with all the features you see here, code completion, introspection of the API against any GraphQL API, and it will just work. So how do you think about GraphQL in an architectural sense? GraphQL, and I want to highlight this here because this is a common misunderstanding, especially when you start learning GraphQL. GraphQL is an API technology. It sits on an API layer, which means specifically we have a transport layer, normally HTTP, which kind of communicates directly with different clients. And then you have an engine or GraphQL layer, GraphQL Java in this case, which is a general purpose library. And below this, you have your domain-specific data fetching layer. This data fetching layer you build specifically for your own app, and you access data from a wide array of different sources. You can catch it, you can get it from a cache, from a microservice, from a DB, or multiple databases. It's not nothing is specific to GraphQL here. GraphQL only requires you to get data from somewhere. So GraphQL is absolutely agnostic to the actual persistence or the actual way how you get access to your data. Okay, coming back to the 2 pillars of GraphQL I mentioned before, we have a GraphQL schema which describes your API. It is defined on the server. You will changing the GraphQL schema normally means the redeploy of your service or application. It is based on a simple static type system, and you have a schema definition language, SDL, which you use in a textual way to describe your schema. We will see an example on the next slide. The second pillar is the GraphQL query language. It is a custom query language, so it's not SQL, it's not JSON, it's not something that already exists. It's what some people call a domain-specific language, specifically made for querying GraphQL APIs. The clients define the query based on their needs. This is very important. GraphQL is a very client-oriented language. So the client defines what data it wants to access from the server, while the server in general kind of sets the boundaries. Of course, you can't access data which the server does not offer, but the specific query is based on the needs and use cases of the client. Every field needs to be requested explicitly. We saw this before. If I add a new field, I get a new field. If a field is not included in the query, you will not get it. This is on purpose to make GraphQL very precise and not have over or under fetching. So you will never get more or less data than you actually need. Okay, this is actually the schema to the API we just saw in this small demo. It's 3 types. Hopefully it's intuitively clear for most of you how to read this. We have 3 types here. Every type has a list of fields. Every field has again a type associated with, and we have an all employees field, which returns a list of employees. Every employee has 4 fields itself: ID, name, salary, department. And the department itself has again a list of fields: ID, name, employees. The type of the field can be a list marked by this square brackets, and you can also add an exclamation mark to a field, which means it's a non-nullable field. Employee and department ID are always present because it does not make sense to have an employee or department without ID. Because this comes up a lot, does GraphQL also support changing data? Yes, it does. In GraphQL, it is called a mutation. And this is how a mutation field would look like in GraphQL, a mutation operation. So this builds on top of the previous schema. We have here an update salary field, which lets you change the salary for a specific employee. I want to highlight one mental model here. Think about the GraphQL schema for now as a list of types, and every type has a list of fields. This model serves us quite well and is quite accurate overall. So you have a list of types, and every type has a list of fields. Okay, this is the second pillar. We already saw it. It's a GraphQL query. A GraphQL query is a domain-specific language which lets you access the GraphQL API, and these fields you see here match one-to-one the fields inside the schema. So there's a one-to-one relationship. You can't query a field which is not defined in a schema. You need to explicitly define every field you want to query. And on top of this, we see here like these curly braces. This is what we call a subselection. An employee or department are complex objects with a list of fields defined in it, and you need to select the specific fields of a complex object. So you can't just say, give me all employees. This is not enough. You need to actually say which fields of an employee you want to know. In this case, it's ID and name, and then you need to specify which fields of the department you want to have. And then again, you need to specify which field of the employees from the department you want to know. Okay, rounding up this session about this introduction to GraphQL, I want to talk briefly about the GraphQL ecosystem to give you a better overall understanding. The GraphQL ecosystem is based on a specification. The GraphQL specification defines how GraphQL queries should be executed. So it defines basically the two pillars we talked about, a GraphQL schema plus a query language. And I mentioned this before. What did it mean in 2015 when Facebook open sourced GraphQL? Well, actually, it meant two things. Facebook released the spec, so they released this document, which has detailed definitions of what a GraphQL schema and query language should be and how a server should execute it. And they also released the reference implementation GraphQL.js alongside this spec. This was released in mid-2015. And what happened next is Facebook said to the world, to the industry, look at this, we really believe in this technology. If you like what you see, here is how you implement your own GraphQL server in your language, in your technology stack. And this adoption took off, and you will find today GraphQL implementation in basically every language you can think about, from Java to JavaScript, obviously, to Python, to Ruby, to Clojure. So if there's a language, there's a good chance that you have a GraphQL implementation ready to use. Okay, so this was a brief introduction into GraphQL overall. Now we will talk a little bit about GraphQL Java. GraphQL Java is the GraphQL implementation for Java, which should not be surprising now based on the name. It implements the specification I just mentioned before for Java, for the JVM. It's a, like I said, it's a implementation of the specification. To be more precise, it's an execution engine. So the main and sole purpose of GraphQL Java is to execute the GraphQL request as fast and as correct as possible. I started this project mid-2015. I think I released the first version roughly 3 weeks after Facebook open sourced the specification. Like I said, it's a pure engine on purpose. It does not deal with HTTP or I/O. It does not have higher level abstracts. It's focused on providing an engine and an engine only. It is used worldwide, and we actually have an ecosystem of libraries and tools built around GraphQL Java because it is so focused and it just does one thing. It can be used in a lot of different contexts, in a lot of different scenarios. You can find more about GraphQL Java at graphql-java.com. Okay, so because of the limited nature of this talk, and it's not really fun also, I will not go into detail of a lot of APIs. I want to talk a little bit how to think in GraphQL Java. So I want to talk specifically about two aspects here, schema first and data fetches, because these fundamental aspects will get you a long way in understanding GraphQL Java and later even understanding Spring GraphQL. So schema first is this idea of you put your schema in the center of your design and development process. So you don't start with a specific Java class or a bunch of Java domain classes and kind of derive an API from it. You would start by thinking about the use cases and the clients you want to offer your API to. So you will ignore, at least for the beginning, how you would actually implement it and just think about how to design and model a nice schema for your GraphQL API. Of course, there are restrictions in terms of implementation. You can't just make up stuff, but I think this mindset of putting the schema first is important here. You define the schema in SDL. So this textual format you saw is actually not some kind of presentation mode or so. This is actually how you would write your schema, or you can actually do it programmatically. Historically, GraphQL Java has offered a programmatically approach of defining a schema first, because there was actually not an SDL and textual format in the beginning of GraphQL. But Java and GraphQL Java, it's not a great way and not a scalable way to define schema. So the preferred approach, what we recommend today, how to start with your API is by writing your schema in a textual format in this SDL format we saw. And this is also the primary supported way of Spring GraphQL. So again, how do you think about a schema? Because there are a lot of nuances and details maybe, but in terms of a mental model, think about a schema as a list of types, and every type has a list of fields. Important here, every field has a data fetcher associated with it. So every field has one data fetcher. What is a data fetcher? Well, data fetcher, as the name implies, is something that gets data for one specific field and for one specific field only. So the sole purpose is to get data from somewhere. For GraphQL Java, it does not matter from where, as we pointed out earlier. Its only purpose is to get data for one field. If you don't specify a data fetcher, a default data fetcher is provided for you. This is called a property data fetcher, and we will see this on the next slide. Actually, on the next slide. So this is the data fetcher interface. It's very generic. It just lets you access or let you get data from somewhere in a domain specific way, and it gives you meta information about the field for what you want to get the data for, and you can return basically anything. You can return a Java domain object, a map, a completable future to make it async. GraphQL Java supports specific things, but in general, it's totally agnostic to what kind of data you return and where do you return it from. That's the main point I want to convey here. Okay, so this is what I said earlier. Every field in your schema has a data fetcher associated with. And normally you you would not define a custom data fetcher for every field. So this is a quite realistic example here for our schema we saw already for our employee schema. So we defined 3 different data fetcher here for the all employees field on the top level query, for the department for each employee, and then again for the employees of each department. So these are the 3 data fetcher we defined ourselves. We implemented in a domain specific way for our application, for our needs. This is our custom code. This is highlighted by these big green arrows here. The other 5 fields, ID, name, salary of employee, and ID and name of department, they don't have a custom data fetcher. They use the default data fetcher called property data fetcher. This property data fetcher has only one purpose. Its purpose is to access a specific getter, normally of a POJO, which matches the schema. So how it works is your all employees data fetcher would return a list of employee DTO, let's say. And the employee DTO has getters for ID, name, salary. So the structure of your Java object matches the schema structure here. And as long as your schema structure, your schema types matches your Java types at runtime, you don't need to provide any specific data fetcher. The property data fetcher is perfectly fine, and it will access your getters for your object and access ID, name, salary, and ID, name of department. So again, the mental model here is important. You will normally in a real-life API only define a bunch of custom data fetcher. The most data fetchers are actually property data fetcher. Okay, so that was a static view. This is kind of what you define in your schema at deployment time, at build time. And how does it actually work when you execute a query? In order to make this clear, we have the same or very similar query we saw before. We are querying here all employees, the ID name, the department for each employee, and the ID of the employee. So how GraphQL Java would execute this query is by first calling the all employees data fetcher. Then we actually call the 3 data fetchers in parallel. We call employee ID, employee name, and employee department at the same time because we can. It's not necessary to wait on one or each other. So we can execute all 3 data fetchers at the same time. And after this, we can call the department name and department employees data fetcher at the same time. And finally, we call the ID data fetcher for the employee. So I hope this gives you an understanding a little bit how the static definition of data fetchers to field actually are used at execution time by the engine to fulfill your request. Okay, now let's bridge a little bit into Spring GraphQL. Spring GraphQL is for me really the missing gap in the overall developer story. Like right from the start, GraphQL Java was limited on purpose. I knew we could not make a full-fledged integration with every HTTP system out there because it's really built on purpose for the limited for being an execution engine. So this means you can do everything you need with GraphQL Java, but not everything is as simple as and convenient as possible. I will give you an example, an HTTP endpoint. So every GraphQL, real-life GraphQL service normally needs an HTTP endpoint, which takes the GraphQL request and actually feeds it into the engine. And it's not overly complicated, but it's also not completely trivial. And without Spring GraphQL, you kind of need to write it yourself. Because GraphQL Java does not deal with HTTP or I/O in general. So Spring GraphQL actually takes this away from you and gives you an overall story how to set up and run a GraphQL server. So a year ago, roughly, the Spring and GraphQL team came together to kind of make Spring GraphQL happen. And what you see here is basically the result of this collaboration. Spring GraphQL is focused on comprehensive and first-level support. So you will get Spring GraphQL by the Spring team, and you will get comprehensive support. For example, right from the start, we support WebMVC and WebFlex. It aims to be a fundamental building block built directly on GraphQL Java. So Spring GraphQL does not abstract away GraphQL Java. You can't plug it against another execution engine or so. It leverages GraphQL Java directly and to its fullest capabilities. And how we think about Spring GraphQL is it's a building block for more opinionated solution if you require these. So for example, code generation or other more specific solutions can be and probably should be built in the future on top of Spring GraphQL. That's from my side. Thank you very much. Rossen will now take over and give you more details about Spring GraphQL itself.
Hit that unmute button. Sorry about that. All right. Hello from me again. As Andy explained, we started working on Spring GraphQL about a year ago. And we were very interested in creating a solution that's going to be as native and as close to the Spring programming model as we can create it. And it was really great to collaborate together and work with Andy and kind of share what we know about Spring and what he knows about GraphQL, and come to this effort and to this project. And as Andy mentioned, GraphQL Java is a foundation for all of Java, for GraphQL applications. And in that sense, it needs to remain open to different programming models and different ways of doing things. And this is where Spring GraphQL can add a lot of value for Spring applications. So let's start by taking a look at what's actually available in Spring GraphQL. And what we have from the very start, what we began working on is, of course, having transports, because GraphQL Java itself doesn't provide that. And we have HTTP transports for both Spring MVC and WebFlux, so you can choose to run that on either foundation. These are, of course, handlers which will simply tunnel all GraphQL requests, and they will be handled then by the GraphQL Java engine. So these are meant to be completely transparent and just up and running. And we have also a WebSocket transport, which means that you can open a WebSocket connection, and then you can begin to make requests over that connection, multiple requests or stream subscriptions without the need for creating additional requests. Then beyond that, we have support for initializing the GraphQL Java engine, kind of bootstrapping everything. We have support for context propagation from the web layer to the data layer, which is important for things like security. We have support for exception resolution. Most recently, in the second milestone that was just released yesterday, we have support for the first time for annotated controllers, annotated handler methods for the data layer as one possible choice for programming model. And we also have currently query DSL Spring Data repositories can be used as data fetchers. We'll take a look at that a little bit later. And from the very start, we added testing support. We knew that this was an important area to work on. We weren't sure if this was going to be a place where we start from, but as we began to experiment, we found out that it's something that we can provide. And so I'm happy to say that we have pretty good testing support. And to kind of bring it all together, there is a boot starter as well that's going to bring everything together. So let's dive into all that. In terms of the web transports, I mentioned that we have handlers for both Spring MVC and Spring WebFlux. We had a choice whether to use annotated controllers or functional HTTP handlers, and we decided that for this use case, using the functional HTTP handlers was a very good fit. Number one, because we only need one handler. We don't need a wide variety of handlers where annotations begin to be handy. And what these handlers need to do is relatively straightforward. They need to take some JSON input, which contains the GraphQL request, deserialize that, and then invoke the GraphQL engine. And so for that, the functional HTTP handlers as a lightweight API was a very fitting choice for us. We have WebMVC functional endpoints and WebFlux functional endpoints. Both of these programming models are available in Spring MVC and WebFlux respectively. We have WebSocket handlers as well, again, coming in two flavors. One that works on the standard servlet or standard WebSocket API in blocking style, and another one which works on top of WebFlux. Irrespective of whether requests are coming over HTTP or WebSocket, there is a common web interception chain. And this is the main API that applications can use in order to intercept any incoming GraphQL request, to be able to inspect the web request and to be able to potentially customize the execution input before that makes it into the GraphQL engine. And likewise, on the way out, a web interceptor can inspect the execution result in order to potentially make some changes or take any other additional actions. These are some choices that we made from the start, that we're going to invoke the GraphQL engine in async execution mode, because there's a data layer on the other side. Very often, the execution fetching of data is very suitably an asynchronous operation or many asynchronous operations. And there's a lot of value to be gained by obtaining data in parallel. So this is why we have asynchronous execution. And for the web interceptor API, we decided to use Reactor. So this is a core dependency for Spring GraphQL. And this is what a web interceptor looks like. As you can see here, it gets access to information about the HTTP request. And it also gets access to a handler that you can use to delegate to in order to actually submit the request for execution through GraphQL engine. And then before that, you can do some pre-handling of the request, potentially transform the web input, which contains in itself the execution input. And then afterwards, you can use declarative operators in order to perform some additional handling after the request comes back from GraphQL engine. Now, building on top of that, we can talk about security. And with security, because we're executing in the context of HTTP requests and HTTP handlers, the first thing to talk about is securing those HTTP endpoints with Spring Security as usual, as with any web application. So once you apply the Spring Security configuration, you get the Spring Security filter chain, and that gives you authentication so that you know that only authenticated users, for example, are performing GraphQL requests. However, this is very coarse-grained security because there's only one HTTP endpoint on which we process all GraphQL requests. And this is why what you can do beyond that is to apply annotations, including pre-authorized or secured annotations in the data layer. And that is how you can apply fine-grained security to decide who gets to obtain or modify what data. And of course, when we talk about applying those annotations, it's important to talk about context propagation. In Spring MVC, we have built-in support for thread local context propagation from the servlet container thread to the data layer. And this is important because it is not guaranteed that in the data layer, a data fetcher is going to be executing in the same thread as the servlet container thread. You can imagine that some of these data fetchers are asynchronous, and that means that you're not guaranteed to be executing in the same thread. Now, in order for thread local context propagation to work, you need to create a thread local accessor, which is a very simple interface to implement in order to help Spring GraphQL determine which thread local values you're interested in, how to restore them, and how to reset them. And Spring GraphQL takes care of the rest. There is a built-in accessor for Spring Security, for the Spring Security context, which means that works out of the box. As long as you're running on Spring MVC, you should be able to use Spring Security annotations in the data layer. For Spring Web Flux, we have reactor context propagation from the web layer because that's where security context is going to come from in a Web Flux application. And for that, there is nothing further that you need to do. Spring Security context is automatically propagated to the data layer. So as long as your data fetchers are returning Flux and Mono, they're going to be able to access Spring Security context. And these are really, if you look at both of these, the expectations are very similar to what you get with Spring MVC, a Spring MVC controller or Spring Web Flux controller, and how you think about context in each of these types of applications. So here you can see briefly on a diagram, actually, the context, whether it's Spring MVC or Web Flux, coming all the way from the web layer. And then it needs to pass through the GraphQL Java engine and make it on the other side to the data layer. And that is something that Spring GraphQL makes sure that happens. So moving on to the data layer. You'll remember that this is the GraphQL Java API. This is the basic data fetcher contract. You can see here that it gets as input the data fetching environment, and this is what we operate with in order to return the data for a particular field. The data fetching environment gives access to things like arguments, input arguments for the query or mutation. It gives access to other information about the field that we're working on or fetching data for, and so on. And of course, we have to bind these data fetchers to specific fields in the schema, as was explained earlier. And if you're doing that with GraphQL Java, then basically this is what's called the runtime wiring. And you get a builder, and that builder allows you to begin to bind this kind of logic to specific fields in the schema in order to fetch the data. So for example, here you see that we are binding to the query type, which is the top level query type for all queries. And the name of the query or the field under the query is called all employees. And you can see here the lambda expression that has the logic. Similarly, we can work with fields that are more nested below, not below the query, but let's say under another type, which is the department type in this case. And the type name is department, the field is employees, and here we register logic for that. Now, notice how in this case, we actually have to obtain the parent object that has been created as part of the data retrieval. This is the department object, and we in GraphQL Java, we get that from the data fetching environment, and this is what's called the source or the parent object. And from that, we're going to get the ID of the department, and we're going to use it to return the list of employees. And lastly, an example of a mutation, the registering a data fetcher for a mutation. You can see here that we need to work with the input. We need to obtain arguments from the environment. And notice also that in GraphQL Java, there is no way to know what kind of object this input needs to be converted into. This is why typically you will work with, let's say, a map if it is complex input, or a map of maps in order to obtain that data, which isn't the most convenient way, but this is what can be done at the level of GraphQL Java, and what higher level programming models can improve on. So next, we're going to take a look at what we have as one option, which is the annotated handler methods that have just been released with the second milestone. Here you will see a controller, much like a Spring MVC controller, or a messaging controller, or an RSocket controller. Again, the controller annotation in a lot of people's minds is an HTTP controller, but actually from the very beginning, and if you take a look at the Java doc, for example, of the controller annotation, you will see that it is defined more generally as a type of component that provides some sort of controller orchestration logic, and that can be used in a wide variety of contexts. In a sense, you can think of this as a data controller, or a controller which is a level below the HTTP layer, but this is really the API facade, or the API layer in a GraphQL application, where you will deal with query inputs and then create data methods in order to return the necessary data. So again, going through the same set of examples, we have a query mapping annotation, and that is going to define a handler method to return the data for the all employees query. You notice that the annotation does not define anything more than just the fact that it is related to the type query type, and also by default the method name is what the field name is. So in this case, you don't actually need to specify anything further than just the query mapping annotation, and you can see here that that matches to the query all employees field. Next is, again, a more nested field. In other words, not under the top level query, but a type which is accessible underneath that. Now, in this case, we're binding to the type department and the field employees. Where does that information come from? Well, first of all, we have the schema mapping annotation, which is the general form of the annotation for mapping or binding to the schema. The type comes from the object which is being injected. If you remember in the previous example, we had to access that from the data fetching environment as the source. Well, here we can just simply declare it as an argument, and that declaration also gives us information about which type of object it is, and we can match that to the schema. So once again, you don't actually need to specify department because it's already declared as an argument to the method. And once again, the field name comes from the method name. And lastly, the example with the mutation. And in this case, that's pretty straightforward. The method name matches to the field. We know it is a mutation because that's a top-level type and it's in the name of the mapping. And both query mapping and mutation mapping are meta annotations that are actually annotated themselves with schema mapping, which means that all three of these are schema mapping annotations, but query and mutation mapping are shortcuts so that you don't have to say type equals query or type equals mutation as an attribute. By the way, also you can absolutely customize these by using attributes of the annotations. Lastly, notice the argument annotation here and the salary input. This is another benefit that we understand what is the target object that you want to convert that argument input into, and we can make that conversion. Okay, next is exception handling. So GraphQL Java allows registering a single data fetcher exception handler. And that lets you examine an exception no matter which data fetcher it comes from, and then specify errors for the GraphQL response. which is basically a JSON response with errors or data. Spring GraphQL implements a data fetcher exception handler and further organizes the handling of exceptions through a list of resolvers or a chain of resolvers, and they get invoked in turn until one of them resolves the exception. Here you see an example of a resolver that you might implement, and that's basically going to get access to an exception and the data fetching environment, and then out of that you can create a GraphQL error, and that is going to be included in the response of the GraphQL response. Query DSL is an alternative way of creating a data fetcher. If you don't know much about Query DSL, it is basically a type-safe way to express queries in Java. It's a query language that essentially works across multiple data stores. Spring Data has support for Query DSL. Now, in Spring GraphQL, we have a Query DSL data fetcher, and that makes it very easy to take a Spring Data Query DSL repository and turn it into a data fetcher that you can then register and wire to schema fields. And what that does is basically it takes GraphQL query parameters, GraphQL request input, and turns it into a Query DSL predicate kind of in an automated fashion. So there really isn't very much to do. Here is an example where you will have a Spring Data repository that looks like this. Notably, notice the Query DSL predicate executor, that's part of the Spring Data programming model. And here you see an example of how you can use the Query DSL data fetcher to essentially wrap this as a data fetcher, turn it into a data fetcher, adapt it, either for a single employee or for a list of employees. And now you've got a data fetcher, and you can register that against specific fields. And in case you're wondering, actually in milestone 2, we have automatic registration of these because we can notice that this is a repository for employees. And we can also notice that there's a top-level query that returns employees. And based on this match, we can actually automatically detect and register this. But of course, in order to make sure that this is on an opt-in basis, that this is something that you want, we have a GraphQL repository annotation, stereotype annotation that you can use to annotate the repository in order to indicate that it is intended to use this for GraphQL. And once we discover these, we will automatically register them. There is more on Query DSL. You can customize how GraphQL request input is mapped to the Query DSL predicate. By default, it's a straight equals comparison, but that's something that can be customized. And you can also transform the objects that are returned by the repository. You can customize what they become with an interface or DTO projections. So these are some more powerful features that you can also utilize. There is more work on improving Query DSL support that's planned, and there's also a desire to do something similar with query by example, but I'll come back to that a little bit later. GraphQL testing, again, this is a topic that we knew early on that we wanted to get into, that is very important, but we weren't sure if this would come early enough in the milestones. So we began to experiment just basically making HTTP requests, GraphQL over HTTP requests and using web test client, and began to see the opportunities to make that better, and ended up actually having GraphQL tester API from the very first milestone. Essentially, GraphQL tester is a workflow, defines a workflow for testing GraphQL. So it's very similar to, let's say, web test client, but specifically for GraphQL requests. It is a fluent API. It does a lot of things under the covers that are specific to GraphQL, like making sure that responses are don't contain any errors, which is something you would have to explicitly do every time. You can use JSON path to navigate to the data that you want to expect. It gives you data decoding. and makes it convenient to verify data. And there is Web GraphQL Tester, which is a sub-interface of that that is specifically for web transports and give you some extra options. Briefly, here is an example of what that looks like. Here we have a query which is defined as a string, but you can use other solutions with code generation, for example, if you have objects and then produce this query as a string and then feed that into the GraphQL tester. This is how we execute the request here. And then we're going to navigate to this path. And we're going to convert it into a list of strings, and then we're going to verify what it contains. So as you can see, the goal here is to make it as simple as possible to test your server application. And of course, we have a Spring Boot starter. It contains all the usual things that you might expect from Spring Boot, including dependencies, management of the dependencies and versions, auto configuration that, for example, initializes your GraphQL Java instance and discovers the schema in specified locations, uses conventions. It has properties to customize the endpoint URL. It defines callbacks and customizers to make it as convenient as possible to customize this auto configuration. It has some basic metrics out of the box, and it also provides a GraphQL UI page like the one that Andy showed in the beginning. So if you decide to have that, it's available in the Boot starter, and you can browse it and you can use it immediately. There's also a way to print the schema at a particular URL if you want to. Now, the Spring Boot starter currently is in the Spring GraphQL repository, and it has an experimental group ID because the intention is for that to move to Spring Boot proper. We just didn't think that there would be enough time before version 2.6 to properly integrate it into Spring Boot. So we're going to aim for Spring Boot 2.7, and the Spring Boot starter is going to move into Spring Boot proper immediately after 2.6 later this year. And of course, at that point, the group ID is going to change. So working our way towards the end, I do want to bring up something which is quite important. So just like there is collaboration between GraphQL Java and Spring GraphQL, and the intent is for Spring GraphQL to be a foundation for all Spring applications, just like GraphQL Java is for all Java applications. Now, Netflix has a wonderful framework called DJS that has been in development a lot longer. It was open sourced, I think, late last year, but it has been in development for much longer. It has a very rich set of features, and it is built entirely on Spring. There are also other frameworks that build on Spring to varying degrees, but I think Netflix DJS is probably the one that stands out with very complete set of functionality, fully built on the Spring programming model, Spring Boot. And we have been working together to figure out how to go forward, because obviously what Netflix DGS aims to provide, we also aim to provide some of that, and there is a fair degree of overlap. So currently where we're at is that there is an optional bridge. There's an optional starter, alternative starter at the moment that you can use to run the DJS programming model on top of Spring GraphQL core. In the future, the plan is eventually for the Spring GraphQL starter to become the main starter, and we're going to continue to work together in order to figure out the best way that we can integrate. But I'm very encouraged by the fact that we are working together and figuring out the way forward in order to make this easier for the community to make choices. Netflix DGS itself provides a lot of features, as I mentioned. You have also an annotation-based registration model for data fetchers, data loaders, scalers, and more. You have a very useful code generation from GraphQL schema to Java. There's a GraphQL client, federation, and so on. In terms of the roadmap, we're planning a few more milestones for this year. An RC phase starting early next year, and then going GA roughly with Spring Boot 2.7 next year. There's a variety of features that we have on our roadmap at the moment that have come through development. We're going to evolve the controller annotated programming model. We're going to possibly add query by example, a GraphQL client. And for more, we really are hoping to hear more from you. Your feedback matters. So this is why we want you to try this, and we want you to tell us what features are important to you. So with that, I want to thank you for your time and attention, and we're going to switch to a separate room for the Q&A session where we will be joined by other developers on the Spring GraphQL project. So I hope to see you there.
Thank you, Roshan and Andreas. That was a great overview of GraphQL and Spring GraphQL project. I think I have a better understanding of what the project offers and how I may be able to utilize it in my applications, but that was a lot of information to digest. Fortunately, we have a way to continue the conversation. If anyone has any questions or feedback, please join Roshan and Andreas in the Q&A session. Coming up next, Joe Granja and Steve Reisenberg will show us how to get started with Spring Authorization Server. See you then.